So far we have taken up in this case what is a progressive wave and what is its corresponding displacement equation. But for all these waves to be produced, already we have taken up the point that a body or the particle should vibrate. Then only the disturbance is going to be created and automatically the wave is going to be formed in that material medium as such. Now the question is, what are the types of vibrations we have? We can remember this way, types of vibrations. What are the types of vibrations we have? The very first one we call that one as free vibration, or you can even call it as natural vibration. Natural vibration. And the second one we take them as forced vibration. You can even call this one as a sympathetic vibration. Due to the sympathy, the body can vibrate with certain frequency, some other frequency. The third one, of course, a special case of forced vibration, that is what we call it as resonance. So there are three different types of vibrations, majorly two, but out of this one a special case, as a special case we take up this resonance part of it. What are these free vibrations or natural vibrations? Suppose if you take up a body, if a body vibrates with its natural frequency, every body will have its own value of frequency to vibrate. That is what is called natural frequency of the body. If a body vibrates with its natural frequency, which is of course independent of the force that is applied on the body to make it vibrate, then we can say the body is having natural vibrations. For example, a tuning fork you have taken. It is written on the tuning fork 512. A number is written like that. That itself indicates its frequency. So a tuning fork of frequency 512 hertz we have taken. Now when you want to tune that one, or when you want to make the tuning fork vibrate, then we need to apply some force on it. You have to tune that one. Whether you tune it gently or you hammer it, irrespective of the amount of force you are applying on that body, it vibrates 512 times only a second. That means whatever is the force we are applying on that body is immaterial. Whether more force you are applying or lesser force you are applying, ultimately its vibrating capability is 512 hertz only, and it vibrates with its natural frequency only. That is what we call it as free vibration. So if a body vibrates with its natural frequency, that is a point. So we can say if a body vibrates with its natural frequency, right, which of course is independent of the force applied to make it vibrated, that is the point. Then we can say the vibrations of the body are said to be free vibrations. What about forced vibration now? Forced vibration, of course, you can observe almost in every example. Say for example, when you consider a tuning fork and you have tuned that one and its frequency is 512 hertz. When you tune the tuning fork and hold in air, one can understand the air molecules around the prongs of the tuning fork also will vibrate. Those vibrations of air molecules, whatever we are having here, they are to be called as forced vibrations. Another thing, when you tune a tuning fork and keep that tuning fork on a table, the stem of that one on a table, then the table also will be made to vibrate with some frequency. those vibrations we can call them as forced vibrations or sympathetic vibrations. So the second one, what we observe in this particular concept of forced vibration, you just take up. Body will never vibrate with its natural frequency. It is vibrating by force. Vibrating by force means what? Definitely the vibrating capacity or vibrating nature of the body surely depends on the force that we are applying on the body. More force you apply, it can vibrate with a greater frequency. Smaller force, lesser frequency, that means its frequency will not have a standard value like. It once again varies depending on the external force by means of which we are making the body vibrate. That is the concept. And suppose if you take as a special condition over here, resonance. What is this resonance here? If a body vibrates with the natural frequency of another vibrating body. If a body vibrates with the natural frequency of another vibrating body, then we can say both are in resonance with each other. Both are in resonance with each other. And one more important point we have to understand, if a body vibrates with the natural frequency of another vibrating body, or if a body vibrates with the same frequency of the applied force on that, then one can understand the system is in resonance. But in this particular example, the moment these two frequencies are equal, amplitude increases to the maximum. That means the body vibrates with the largest amplitude. That is the reason why whenever resonance occurs, huge sound will be produced there. So one of the best examples you can take for resonance. One, tuning a radio to a particular station. If you want a particular radio station to be heard, you have to tune your radio to the same frequency of that radio station as such. Then only you can hear the program of that station. That is one example. And second one, army people are not advised to march on suspending bridges or hanging bridges. Reason, of course, we all can understand directly by taking resonance. When they march on the hanging bridge, then the hanging bridge also vibrates. If it vibrates by any chance with the same frequency of the march past of these people, then automatically amplitude increases to the core and huge sound will be produced and that bridge may break down totally. That means you are not supposed to march on hanging bridge whenever we consider resonance into account. So army soldiers are advised not to march on hanging bridges like. Likewise, of course, in resonating air column apparatus, whatever we use to determine the value of velocity of sound at room temperature and thereby to estimate its value at 0 degrees centigrade, we use resonating column under the concept of resonance as its principle. So principle of resonating air column, we are making use of that one for taking up or determining the value of velocity of sound. So resonance is a kind of forced vibration. A kind of forced vibration, no doubt. But the point is, here in forced vibration, you will never have the frequency similar to the other vibrating body making it vibrate. Whereas in the case of resonance, both used to vibrate with the same frequency. One vibrates with the natural frequency of another vibrating body, which is used to vibrate the second body as such. And in this connection, you will be finding the amplitude increases to the maximum and automatically huge sound is going to be produced. Another basic example also we can take up. Sometimes earthquakes occur. When tremors occur at a particular place, there is no rule that all the buildings in that locality should collapse. And we also might have seen many a number of times. You might have seen many a number of times on TV screens and other like. All the buildings in that locality will never be collapsed. Those buildings or those constructions which come under resonance with the frequency of the tremor, only those buildings will collapse. So this is actually the concept one has to understand as far as resonance that is concerned. So the general types of vibrations when we consider free vibration, forced vibration, a special kind of forced vibration, that's what is called as resonance. These are the things one has to remember.